It is the lightest gas, highly flammable, and it can produce a pop sound. Can you guess which element we are talking about? Yes, the lightest gas that can explode, it is the hydrogen gas. So in today's video we will be discussing about the properties of hydrogen gas, its occurrence, and how it can be prepared from different metals. Okay, so let's get started with few basics for hydrogen gas. What exactly is hydrogen? Very simple. Hydrogen has a symbol H. Its molecular formula is H2 and its atomic number is 1. Now the atom of hydrogen has got one proton and it has got one electron, and that is the reason hydrogen is the first element in the periodic table. Okay, so the atomic structure of hydrogen is clear, one proton and one electron. And talking about what is making hydrogen so special, the special property of hydrogen is that it is the lightest element and it is the most abundant element in the universe, and that's why hydrogen is found in stars including our sun. So if hydrogen is so light, would you expect it to be heavier or lighter than air? Because it is saying lightest element, you will remember that it is the lightest element as compared to air. So it is lighter than air. Next, coming to the discovery of hydrogen, we have three scientists. Firstly, we have Robert Boyle. He established the elementary character of hydrogen. Henry Cavendish observed that when hydrogen is burnt in the presence of oxygen, we get water. Okay, so this was an important aspect that was established by Henry Cavendish, and Anthony Lavoisier gave the name to this gas. Okay, so this name of hydrogen comes from the Greek word hydro and gen. Hydro means water and gen means producer. So the real meaning of hydrogen gas is water producer. Okay, next question, we see that where is hydrogen found? Now hydrogen is found both in free state and in combined state. In free state we find it in minute traces in the earth's crust, atmosphere, and in the volcanic gases. It is also found in the sun. Earlier also we had seen that it occurs in the interior of the sun, which is mainly made up of hydrogen, which is constantly being converted to energy. It is released as heat and light. Now in the combined state, hydrogen occurs in water. That is the simplest example you can remember. Then in acids also we see hydrogen being formed in the combined state like HCl, nitric acid, and in organic compounds. Okay, organic compounds having carbon, hydrogen, oxygen, all this in organic compounds like proteins, hydrogen is the main element. And then in the tissues of plants and animals also we get hydrogen that is being present. Okay, so in plants and animals also the compounds of hydrogen are present. So mainly in majority the hydrogen is found in larger amounts in combined state as compared to free state. In free state it is found mainly in traces. Okay, now the very important question in this chapter is how do we prepare hydrogen? That is the big question which we are going to discuss today. So mainly under four headings, that hydrogen can be prepared from water, from steam, from dilute acids, and from alkalis. So we are going to understand the pattern as to how hydrogen can be prepared. So firstly, seeing the metal activity series, in the previous lesson also we had seen that it is a series of arrangement of metals in order of their reactivity. We know the most active metals are at the top and the least reactive metals are placed at the bottom, and hydrogen acts as a reference element. So all the metals that are above hydrogen, they can easily displace hydrogen from acids, whereas all the metals that are placed below hydrogen, they will not be able to displace hydrogen from water or acids. So firstly, talking about the preparation of hydrogen from cold water. Okay, in the presence of cold water, if we see the reaction of potassium with cold water, we get potassium hydroxide being formed and hydrogen gas is liberated. Okay, so this is the first reaction which you can remember. So what is happening when the metal is reacting in the presence of cold water? We are getting a metallic hydroxide being formed along with the liberation of hydrogen gas. Another reaction with sodium. Now potassium, sodium, calcium, these are the highly reactive metals. So sodium, when it reacts with water, what are we getting? We are getting sodium hydroxide being formed along with the liberation of hydrogen gas. So you have to understand the pattern, understand the sequence. So potassium, sodium, highly reactive metals, but they are reacting with cold water and they are forming the corresponding metallic hydroxide, and hydrogen gas is being liberated, and the reaction is highly vigorous and exothermic. So generally we don't prefer these methods because the metals reactivity is very high. Next we will see the reaction in the presence of steam. Okay, and we are taking the metals from magnesium till iron, magnesium, aluminium, zinc and iron. So these will react with steam, not with cold water. So when magnesium reacts with steam, H2 we are taking in the form of steam, it will form the corresponding metallic oxide, very important, metallic oxide, and hydrogen gas will be liberated. Another reaction is with iron. Now this reaction is a reversible reaction, again a very important reaction. At times in the exam it is asked which metal reacts in the presence of steam and the reaction is reversible. It is iron. Okay, we get iron oxide being formed and hydrogen gas is liberated. Okay, so the reaction of iron with steam is a reversible reaction, and what we are getting the corresponding metallic oxide and hydrogen gas being formed. Next we are going to see the reaction with acids. Okay, metal reacting with acids, again from magnesium till iron we are going to see. So magnesium, now this is an important reaction. Magnesium, when they react with dilute acid, we get the corresponding salt being formed and hydrogen gas is liberated. Another reaction we see with zinc. Zinc, when it reacts with sulfuric acid, again we are getting the salt, zinc sulfate being formed and hydrogen gas is liberated. Okay, so these are the two reactions which you can remember with acids. So the basic concept which you will learn over here, acids when they are reacting with metal, they are forming the corresponding metallic salt and hydrogen gas is liberated. Then last preparation we see from alkalis. We are going to see concentrated alkalis. So zinc, when it reacts with sodium hydroxide, which is an alkali, it forms the corresponding salt, sodium zincate. Very important formula. In the examination also it is asked what is the formula of sodium zincate, Na2ZnO2. And with lead, when it reacts with the concentrated alkali, we are getting sodium plumbite, Na2PbO2, and again hydrogen gas is liberated. Okay, so here we are getting the corresponding metallic salt with the liberation of hydrogen gas. Okay, so what we have discussed about the preparation, which is very important here children, we are seeing the general methods for the preparation of hydrogen gas. In general methods we have listed out from water, that is firstly we saw the preparation of hydrogen gas from cold water, then from steam, then dilute acids and from alkalis. So under these four headings we have discussed the general methods for the preparation of hydrogen gas. So if we have to answer this question, can you answer now? Out of these three metals, magnesium, zinc and copper, which metal will not liberate hydrogen from dilute acids? Can you answer? If you see the positioning of the metal, yes, the correct answer is copper, because it is placed below hydrogen. It will not liberate hydrogen from dilute acid. Okay, so let's summarize what we have seen in the preparation. Firstly, we saw the preparation in the presence of cold water. Which metals were reacting? Potassium, sodium and calcium. And what were the products we were getting? We were getting metallic hydroxide and hydrogen gas was liberated. Okay, metallic hydroxide and hydrogen gas was liberated. Then we saw in the presence of steam. So in the presence of steam, which metals are reacting? Magnesium, aluminium, zinc and iron. And when these metals are reacting, they are forming the corresponding metallic oxide, and again hydrogen gas was liberated. Okay, so that way you can remember the method and you can remember what is the reaction that is happening and what are the products formed. Then next we saw with dilute acids. With dilute acids, again which metals were reacting? Magnesium, aluminium, zinc and iron, and we were getting the corresponding salt and hydrogen gas being liberated. And then lastly with concentrated alkalis, again the metal reacting were zinc, lead, aluminium. Here also we are getting salt and hydrogen gas being liberated. So these were the preparations which we have summarized. So moving on to the rapid fire challenge, let's quickly answer. Let's see how many you can get right. Which is the lightest element? Options are oxygen, hydrogen, nitrogen, helium. Yes, the correct answer is hydrogen. Moving on to the next question, which metal reacts with steam to produce hydrogen? Copper, silver, magnesium, gold. It is magnesium. Moving to the third question, which metal is below hydrogen in the activity series? Now this is simple. Zinc, iron, magnesium, copper. Which is below hydrogen? It is copper. Then moving on to the last question, which gas is liberated when zinc reacts with dilute sulfuric acid? Is it oxygen, hydrogen, carbon dioxide or nitrogen? Correct answer is hydrogen. Okay, so I hope you have understood and we have discovered how hydrogen can be prepared using water, steam, acids and alkalis. So in the next video, which will be a very important video, we will discuss the lab preparation of hydrogen and we will also understand why hydrogen burns with a pop sound. So see you in the next chemistry class. Thank you.